I hope you are good and doing well for the preparation of your upcoming CAI's exams. Guys, the topic what we are going to discuss today, that is about the volume of revolution. For this, before we start the solving few questions on based on this topic, suppose we consider uh, the area bounded by the curve, say y equal to x square, rotated, yes, about x-axis, about x-axis, and the lines, say x is equal to a and x is equal to b, where a b are integers, where a and b are integers, lying on x-axis. So let's see the figure. If I draw this one, I will get this. This is x-axis, this is y-axis. So y equal to x square, so positively we can say this one is from 0, y equal to x square, as x is a and b, they are integers. Suppose this is a and here it is b. So this one is the area what we are looking for. Consider area bounded by the curve this about the x-axis. The line x is equal to a, x to b, where a, b are integers lying on axis. Right, fine. So for that. So when this area is rotated, when we rotate this area, the shaded one, I shaded with blue, about the x-axis. So rotation will be, I want this kind of rotation now. So let me redraw it again, like this. Because guys, it's very important to first make the concept of rotation, and then you better can apply the simple rule or formula to finalize your answer. Suppose let me redraw it again with this pen. Suppose it's 0 and y equal to x square, and this was a and b. As we have to rotate this one along x-axis like this. So if we can hold this open end in top end, the blue one, I'm going to circle blue, in your hand and start rotating like this about x-axis. One thing before we rotate, keep one thing clear, this x-axis, this line x-axis becomes the line of symmetry. I need to draw this with black to define it, because you're rotating this about x-axis through 360. Yani here what I'm doing, I'm rotate y equal to x square about x-axis through 360 degree. You will see what will happen. And as I told you about x-axis, so this line x-axis here, the black one, will be the line of symmetry for once I start rotating it along x-axis. You will see the figure will be like this. So I'm going to rotate it in smaller circles, yeah, like this and this. Starting from an x-axis, you will see that this will be like this. So I will get a solid of revolution in this way. Then a solid of revolution is formed, and the volume, if you want to find the volume of this solid, is called the volume of revolution. Got it? So it means once you start rotating this one, and this was the shaded part between A and B, I need to reshade this one. When you rotate this one along x-axis, then the same at the same boundary, limit boundary, that this one will be formed, and it makes a solid. Once you start rotating around 360 around x-axis. Okay. Similarly, we can redraw. We can write the rule, the formula, to find the volume of revolution for this single curve. That will be defined as the V is equal to pi times the boundary of the shaded curve in which it is going to rotate, the region it is lying between A and B here for the above case, and function is f of x d of x square, because integral of the area square will always give you the volume. So this is the formula. Any function square along x-axis dx, limit a to b and pi, that represent the volume of a solid of revolution revolving rotating about 360 along x-axis. And even we can approximate this volume by finding a series of cylinder disk or thickness of delta x. Even there's another way, but the most appropriate and simple way to find this is this, to apply this rule to find the volume of revolution. Let's see more figures to discuss about. Now suppose we have this, wrong, x-axis, y-axis. If we have okay, we can make a line 0, y equal to x, and now we want to rotate this line about here. I'm going to write rotate y x about y-axis to 360 degree. Now I want to rotate this along y-axis like this, so I need to hold this end, the blue one, and I need to start rotating like this along y-axis. But before we rotate, we should know the other side of this y-axis. This y-axis become what? The line of symmetry, as we have discussed in the above case, that when the curve or the line is rotating about x-axis, then x-axis becomes the line of symmetry. Now here the y-axis. So we need to draw this dotted line, straight line, that represents the mirror image along y-axis, and you will see once I start rotating it in a circular path, and like it will be like this. It becomes a small circle, and you can keep increasing on it. And because it is a straight line, so it's shaped like a shape of a cone, and we can prove the volume formula of a cone with the help of this rotation method. And this is curve along y-axis. Fine. So the rotation will be taken place, but before this we need to find one more thing here, the area shape. Say here I'm interested to find this area shaded by this line, that is along y. C and D is the point where it is confined by the line. I can write the question back in consider the area bounded by the line y equal to x, the y-axis and the lines, that is y equal to C and y equal to D here, this time C and D, where C and D are the integers, like we did in the first example, long x-axis rotation, integers on y-axis. So we want to rotate this one now, and as I told you, the rotation will be taken place here like this, and this again, this and like this. So if I can see the reflexes of this rotation, this red one be the reflexes, and we can see a solid of revolution has been formed again. So this time, as it is rotating about y-axis, so we can say the volume of this solid is called volume of revolution about x-axis, and can be formulated as v equal to pi times integral, the range of this shaded part is C to D. Now this is about y-axis, so we need to make the x as a subject, so f of x square d of y. So here in this rotation about y-axis, you need to keep one thing clear, that should be the function of x in term of y. So make the x as a subject and apply it over here and integrate with differential of dy. So this is the rule when a solid is going to revolve about x-axis or y-axis. This is and now see few questions to help us to make more understanding about this. Okay guys, now we are going to solve a question, that is find the volume obtained when the shaded region is rotated through 360 about the x-axis. It means rotation will be taken along this axis. So x-axis will be the line of symmetry. Drawing is not as important, but only the concept. So in the above discussion, we know that the volume of revolution of the object when it's rotated through 360 along x-axis is pi times the a to b f of x d of x, right? Right. So here what is f of x? Here f of x is 9 over, so we will be pi times limit a to b is 1 to 2, so 1 to 2 limit of the integral, and the function become y is what, 9 over 3x plus 2 d of x. So just integrate it, and before you integrate, we can take common 9 constant outside of the integral, and the denominator function once will bring in numerator, it becomes minus 1. Sorry, this was what was the function here? This is the board, rotating board. Yeah, and the rule says that we have to put the square here, right? So we didn't put the, we squared it, so it becomes minus 2 up here, and this 9 square becomes 81 here, right, as per rule. Because here we can see the rule, that is f of x square, because y equal to f of x, so f of x square. Okay, so we did the square. It becomes, when it's bring it up, it becomes -2. So the basic rule of integration here I'm going to write for you for your sake of revision: ax plus b power n will be 1 over a times n plus 1, and it is here ax plus b power n plus 1 plus c, right? The rule has already been discussed in the previous lessons, so you can check it. So here a is 3, so I will write 81 pi, and it will be 3x plus 2. Once we add 1 in the power, becomes -1 over 3 times of -1. And because it's definite integral, so we will not put c, only the limits of the integral here. So further simplification, 81 pi. Now what to do? We can apply the limits rule, the upper limit minus lower limit, right? You can take this -3 outside and put it here. It doesn't affect it. It will be 1 over 3x plus 2 power 1, limit 1 to 2. Now apply the upper limit minus lower limit. It's a minus 81 pi by 3. We will solve it laterally. Upper limit becomes, once you replace this x with 2, 2 times 3 is 6 plus 2, 8, minus lower limit 1 over 3, 1 3 plus 2, 5. So you can simplify and help calculator, and it will be minus 81 all pi, and 40 become the LCM, 5 minus 8. So you can write minus 81 pi over 3 times minus 3 by 40. 3 cancelled. So the required volume becomes minus plus 81 pi by 40 unit cube, or you can write 2 whole 1 by 40 pi unit cube. That is the answer for this question. Okay, so don't forget to square the function, right? Because it's the area, square of area with the integral. Okay, now take another example. The volume of the revolution when the shaded region is rotated, this time about y-axis, 360 about y-axis. So again, this means y-axis is a line of symmetry and we need to rotate it. Simply apply the rule. What is the rule when the function is rotated about y-axis? Pi times integral c to d f of y square dy, as we wrote it here. Yeah, here. F of, instead of x, sorry, write it here y for your sake of information. Yes, write it y dy. So you can see x is equal to f of y here. We need to, I told you, because of rotation taken place along y-axis, we need to make x as a subject. So sorry, so guys, oops, we are going back to this question. So as it is has been taken along y-axis, so rotation is like this. So the formula is over here. Now apply this. B is equal to what? Pi times, limit is 2 to 5 was the shaded part, f of y. So first we make x as a subject here, as y equal to x square, so it means x will be plus minus square root y, right? So here we will plus minus square root y square d of y, that gives us pi equal to 2 to pi, again it will be y dy, right? because plus square or minus square will be y, so it will be eliminated. So it means x square is equal to y. So I put it here, y by time integrated y square by 2, limit 2 to 5. So v equal to pi by 2 is outside, so y square 2 to 5 pi by 2 upper limit 5 square minus lower limit as per rule. So pi by 2 25 minus 4 will give us final answer 21 pi by 2 as volume, so unit cube. I hope it is clear. Okay guys, this time we are solving this question, that is find the volume of the solid obtained when the shaded region is treated through 360. About the first case is about x-axis and second along y-axis. So this is a figure, and the curve that is going to rotate, that is function is 2x square plus y square equal to 9, right? And first case is stated about the y-axis, that's rotation, rotate 360 degree about x-axis. So it means we need to first find the limits of the function along x-axis. So here it is clear from x-axis it is 0 here, and as a point 2 1 state given, so we can say it is lying here, axis 2 here. So the limits along axis is very much clear. So then we can apply the rule, that is volume is equal to pi times integral a to b, then a function of y, any f of x square d of x. So you know, for your record, f of x equal to what? Y. So first we need to make y as a subject to write it here. So given question is function is this 2x square plus y square equal to 9, and this will be y square equal to 9 minus 2x square, because this will be as pi times a to b y square d of x, right? Because we know this thing. So just apply in the formula. And one more thing, it is also given when it is rotated about x, as you can see, this is a line, this is gap along the x-axis. Here we have two cases to study. So let me draw it for you again roughly. See, this was the original curve, this was a line, that is y equal to 1 at point P21, and this is a curve. Once we rotate it along x-axis, x-axis becomes the line of symmetry, this becomes the line of symmetry, you know. Then if I draw it again, it will be like this, and x is equal to 1, so it is y equal to minus 1. If it is y equal to 1 and bottom of the x-axis, it will be y equal to minus 1. So this, and if it start rotating it, you know, circular along y-axis, so it will be like this and this, it start rotating like this, and you can say along x-axis this case will be taken place. Along x-axis rotation, this will be taken place, the shape will be like this, solid is formed. But here if you can see, okay, let me do this again. Don't forget the rotation is taken along x-axis here. These shaded parts keep this hollow parts, H part, that is not going to be shaded. So we have two approaches. One thing, we can find the area of the shaded part and minus the area of this, because this makes a slender, the hollow part will make a slender like this, you can see. it will make a cylinder once you start rotating. So out of this total solid of volume, we can minus this area of cylinder to get the answer. Or another approach, that approach says that this is what we have a line. Let me remove this. Yeah, okay, as this was the line y equal to x, and once we will rotate this curve, the line will also rotate here. So outer one is what? The top one is the curve and the bottom one is the line. So equation of line is y equal to 1. So we can through our answer here, we can change the formula, that is lying between pi times along axis, the limit will remain same, a to b, the y square of curve minus y square of line and d of x in function of curve and a line can be minus to get the answer. And here, as you know, line is equal to what? 1. So we just replace it, pi equal to limit is what? 1 0 to 2, y curve we have find it here, that is 9 minus 2x already to square, minus what was y equal to 1, the line. So square will be remain 1. So we can say minus 1 square d of x. So apply integration rule. 9 becomes 9x and 2x square becomes 2x cubed by 3 minus 1 square is 1, 1 becomes x and the limit is 0 to 2. Do the basic calculation. First we will replace upper limit minus lower limit. Pi will remain pi. Even this time we are countering the problem with curve and a line. So the area between the curve and the line, as we have discussed in the past videos. Now by keeping that concept, we are applying the condition for the volume of solid, the difference of the two. So 2 9s are 18 minus 2 by 3 and 2 power 3 is 8 minus 2. This is the upper limit minus, now lower limit 0. Once you replace 0, 0 and all terms become 0. So no use of it. So 18 minus 16 by 3 minus 2. So further solve 16, 18 minus 2, 16 minus 16 by 3. Taking LCM or use the calculator, 48, 16 3 is 48 minus 16 by 3. So 32 by 3 pi unit cube is the required volume for this case once this object is rotated about y-axis, x-axis. Now we are going to solve the same case when this shape is rotating about y-axis. Let's see how to solve. Now guys, now we are going to find the volume of solid revolution when this shaded region is rotated about y-axis, right? Now the rotation is taken along y-axis. So y-axis become the line of symmetry for this rotation. And if I can show you here the figurative representation for this line of symmetry, and so this will be like this. So this becomes the volume of solid of, yeah. Here for this case, we just need to get the limits. Here no use of this line because here only the shaded region is confined about y-axis. So other limit of y will be taken from here to y square, x square by y square is equal to 9. So at y-axis we know all the x components are 0. So here we get y square equal to 9, y equal to plus minus 3, as it is above the origin, so we'll take y equal to 3. So here the other limit is 3. So applying the rule for this volume of revolution, solid of revolution, you know, here only this one. So now no use of this line y equal to x. So single case y pi times c2d, so x square dy, right? So what will be the function of x square here? Because here x is equal to f of y. So find the x square first. From 2x square equal to 9 minus y square. So x square will be 9 minus y square by 2, or you can write it as 9 by 2 minus 1 by 2 y square. So apply in the formula, we will get pi times limit is what? 1 till 3. So 9 by 2 minus 1 by 2 y square dy. Now apply the basic principle of integration. First one, 9 by 2 is a constant, so 9 by 2 of y, and y square will be y cubed by 3, and limit 1 to 3. So further, before we apply the limit, you can further simplify it. 9y by 2 minus y cubed by 6 and 1 to 3. Now apply the limits. Let's see what comes. The result will be, here you need to be very careful while applying the limits. First, we always apply the upper limit in place of variable. So 9 times 3 is 27 by 2 minus 3 times 3 is 27 by 6, because this is 6, minus the lower limit 1. 9 times 1 is 9 by 2 minus 1 power 3 is 1 by 6. Now you can simplify further. We will get pi is common for all. We can say 3 2 the 6, 3 9 the 27. Oh, we can simplify this. 27 by 2 minus 9 by 2 minus here 9 by 2 minus 1 by 6, or you can use a calculator to get your answer, right? I'm doing the simplification. Mental calculation is, that is 2 is LCM, 27 minus 9 minus here becomes 6 LCM. So you need to multiply this with the 3 and divide with 3 to become geometry same. So 3 is 27 minus 1 by 6. Volume is pi times 18 by 2 minus it becomes 26 by 6. Okay, further we can write it as 9 minus 13 by 3. Pi is common, so further take the LCM. 3 is the LCM. 3 another 27 minus 13 will give you 14 pi by 3 unit cube is the final answer. When this curve, this is 2x square minus y square, is rotating about y-axis. So here it's very much clear that what will happen when the object or the area is of the shaded part is rotated about x-axis. So you can see x-axis, as because of this space, this create a hollow cylinder or a hollow space that will form a certain shape, right? So for example, if this is along horizontal line, if it along with the curve, so along x-axis we get the two things, a curve and a line. So we get the area square, difference of the area integrate it, and we got this, because here we get this rule for the two curves or a curve or line that is going to be confined within the certain shaded area. So I hope it is clear, and we can have a lot of more examples to solve on it. So I recommend you guys to follow few practice question I'm going to give you here in a short while. Okay guys, after all this discussion we made it, now I assigned you few home questions as a homework. Yeah, you can attempt it, and along with the questions I mentioned the answers to justify that your calculation is you did right or wrong. You can check it accordingly, right? So here's the question 1, 2, 3, and 4. So I hope after listening the videos and its concept, you better can solve all this in a convenient way. Wish you good luck. See you in the next video. Allah Hafiz.